Okay, we're live. Welcome everyone who's watching. Hey, hello out there. We are kicking off the Injective and Google Cloud Illuminate workshop series. Super excited to kick this off with the first workshop with Adrien, who's a Web3 principal architect at Google. Hey, Adrien, welcome to
Hey,
the
yeah,
workshop series. Any
thank
opening
you.
thoughts? Where anyone who's watching, any dev who will be building in the hackathon, any suggestions for them to get on to their building journey?
For me, the question?
Yes. Yeah. Any
Yeah,
opening
so
thoughts to share
y-
with the devs?
yeah, no, I think so. Yeah, I think it's a great initiative, right? Obviously, I'm very excited about that. Hopefully, you can get some learnings from what I'm going to present. Maybe give some ideas as well. Uh, but I think after everything that's been going on for the past year, it's exciting to see things picking up again. And I think it's a great momentum. Very exciting to be here, and good luck to everyone.
Absolutely. So yeah, I think with that being said, Adrian, let's get started. And anyone who's new to the workshop and the hackathon in itself, I would say this is a prime builder launchpad for any Web3 applications you ever had in mind. So if you've been thinking of building something around Web3, DeFi, NFT, social dApps, so this would be your chance to kick that off. And yeah, with that being said, Adrian, let's go with the content.
All right, thank you very much. So today we have a kind of like a pretty packed agenda. I want to start a little bit talking about what Google is doing in the Web3 space. I want to talk specifically about data sets and what we do around that and how you can leverage that maybe for the hackathon. And then I want to talk, of course, about Google and Gen AI. That is a very big topic these days. And same here, giving some ideas of what people have built, some demos of what Google has been building also on the Web3 and Gen AI space. And then, because it's a hot topic as well, wanted to give a short intro to ZK and how you can leverage it on the Google platform. And I'll just finish very briefly with one slide explaining a little bit what the starter program is that we have at Google and how you can leverage that to get free credits and some deals with some tools like Alchemy. Before getting started, just very quickly about myself. So Adrien, I'm now Web3 principal architect at Google. I've been working in crypto for the past 9 years. I started working on real estate tokenization, and then I've been like freelance dev on some projects and so on. And then I worked for ConsenSys for about 4 years. So I worked a little bit on Infura, MetaMask, and Linear now that you must know about. So yeah, very excited to be here and talk about this agenda. I think we'll have a Q&A at the end of the session. So yeah, if you have questions, don't hesitate. All right. So Google, I know for some people, but might be a bit strange to hear about. Okay, what is Google doing in the Web3 space? I think it makes a lot of sense, right? And the question I get a lot, and I'll get it out of the way, is why is Google is centralized? What are they doing in the Web3 space? Well, I think a lot of services are centralized, right? Like when you look at Infura, Alchemy, those are centralized services. It doesn't mean that it doesn't help the space. The builders, the startups, they would need services and good services to get started. And then when you reach like some critical mass, and you have a company that is getting bigger, then you can have your own nodes and stuff like that. But I think there is a lot of things that we can do around analytics, around AI, around running nodes that are very critical to the space and helping the builders getting started. Right. So that's really the idea of what we do in Web3. And so the vision that we have is that we really want to make it easy for Web3 products and Web3 startups to build. We want to, create stuff that are efficient, reliable, and so on. Same as what we're doing and providing for the Web2 space, but we want to basically extend it to the Web3 space. The goal also, and maybe you've seen like some kind of like we've done some bounties. We work a lot with the community. I mean, such as this hackathon, for example. So we really want to combine effort with the community, right, and push things together. Okay, so Google Alphabet, right, is doing a lot of things in Web3. It's not just Google Cloud, but I think Google Cloud is really at the forefront of the Web3 space at Google, right? So we have a Web3 expert team on APAC that I'm part of, but we also have a lot of people working globally in the Web3 space. We're also going to accept crypto payments for Google Cloud soon, and that's pretty exciting. We have Google Labs, Google X, formerly, that also has a team that is working on like the protocols themselves, and trying to do some R&D and like research and development around that. Web3 is also governing member of the Hedera networks, but we're also a validator. We run validators for EOS network, Ronin network, Polygon, Ethereum, and so on. And I think that's really something that we want to continue doing to bring decentralization, trust, and kind of like security to the different networks that we are part of, right? So that is very important and core to us, right? Doing these Web3 partnerships. And then also Google Pay has done some partnerships in the Web3 space. And we also have two, like a VC from Google GV and Capital G who are investing in Web3 companies. So maybe you heard about there was an investment done in Fireblocks, but also, and that I think is pretty cool, was an investment on Yuga Labs, right? So Bored Ape Yacht Club by Google. So yeah, that's pretty much sums up a little bit what we're doing at Google in general in the Web3 space. Specifically for Google Cloud, we have obviously a lot of customers building on the Google Cloud platform, and we are really trying to tailor products and services for Web3 companies. So you have a few examples here of what we can do and what are the added value of them building. So specifically in Web3, right, what we can do is we can divide what we offer in two categories. We have the products kind of offerings, and then we have the kind of like partnership aspect, right? So in terms of products, we have a blockchain node as a service. I won't talk too much about it, but it's basically you can have dedicated nodes for Ethereum, Solana, Polygon, so far, and then we're going to add networks. But it's basically a fully managed dedicated node, right? So you have other companies that are doing that, but here we're giving the Google kind of like resiliency, latency, and so on. That is quite good, right, for builders. So we have this service. We also do have a lot of experience running self-managed nodes for a lot of different networks for the different customers that we've helped. And so you can of course do that on specific VM, but you can also do it on Kubernetes, for example. And the last thing is the data set. So that's really like, okay, how do we index the data from the chain and give it accessible to as many developers or builders as we can. That's really the goal of the blockchain datasets. But I'll talk a little bit more specifically on the dataset in a few slides. But that's really the idea of indexing the data. In terms of partnerships, I said, right, like Google is running these validators, so Schemavis, Solana, Polygon, Tezos, and so on. Those are just examples of what we're running. But we're part of the network, so we are validating these networks, which we think is very important. I said also working with the community, creating some kind of ecosystem with VC accelerators, creating hackathons, doing bounties. We have the Web3 startup program, and then we involve Google as one. Right? It's not just, maybe you've seen the Play Store recently did some announcement to have NFTs supported on the Play Store. So this kind of stuff we're doing to really have the whole of Google involved. Okay, so on the data set specifically, right? I just want to talk about that, and the reason why I want to talk about it is because Injective chain, right, has a data set that you can access, and so you can play with it, and you can use it to build. I will show you some examples, but you can use it to build some dashboards, some explorations tools, some analytics tool, or even the apps, right? yeah, I'll talk about that. But basically, what dataset is basically the idea of having on BigQuery some public datasets or some datasets that can be used by anyone. And this data is coming from the blockchain, and so we are indexing the data from these different chains into BigQuery, right? So right here you have we have 2 or 3 kind of data sets that we offer. We have the community run ones. So you have here, for example, like Solana, Tezos that you have on the right side here that you can query. And then we have also so what we say by community is that the ETL pipeline that is basically translating the blockchain information that we get and that is injecting that in the SQL database of BigQuery is community based, right? So the GitHub is open source, and we use this to basically run the nodes that are extracting this data. And then we also have the Google managed one, so it's the same price, and it's basically Google who is running the indexes and then pushing these data on BigQuery. And so you have the list here of what are the Google ones versus the community ones. The only difference is that the Google managed ones would have like a specific SLA, right, and data quality controlled data, right? So that would be the difference between both. But when I say you have to pay for it, you have to pay just for the querying of the data. So basically, Google is absorbing for running the indexes. So basically running the nodes for Polygon, Bitcoin, Arbitrum, Avalanche, and so on, and then decoding some events, and then run the ETL pipeline and pushing this data to BigQuery, right? So Google absorbs the cost of running these indexes, the ETL pipeline, and so on. And Google also absorbs the cost of storage, right? So we pay for the storage of petabytes of data for all this blockchain. And basically what the users pay for is only for the querying of the data, right? And the pricing is the same as BigQuery pricing, which is very good pricing, right? So I think as a user, you have something like 1 terabyte free per month or something like that. So if you want to do some queries, or if you want to build a tool, that will cost you, some dollars. But if you want to use it for building and so on, that will be basically free. So what you can start to do with that kind of data sets is to start having insight without having to run a node, especially an archive node, because that takes a lot of time and effort to set up, but also to store and to run. And then you can create your own SQL queries without relying on APIs that would maybe not give you specifically what you need. So you have full flexibility here to do whatever SQL queries that you want. And so it's a great traction whether you're a small or a large player, right? So very quickly here, and the reason why I show this slide and how it's built is just if you want to run an ETL pipeline or some indexer yourself, then you have a starting point, and of course the Google team can help you do this kind of stuff. But basically the idea is, you see on the one here, we basically use Kubernetes to run nodes, so archive nodes for Ethereum, for example. And then from here, we are going to run, we are going to stream the different blocks and push that with PubSub to ETL pipelines. So we're going to do some decoding operations, events, and so on. And we're going to then transform this data and push that into an SQL BigQuery table, right? And so that's basically the architecture. That's what we're running behind the scene to have these kind of data sets ready to use. So in order to have access to the Injective dataset, you would need to fill out the access form that is here from the Google Cloud platform. You can go to Analytics Hub. You can search for the Injective dataset, and then you can request access, and then you will have access to SQL tables with all the data from Injective. And so here you have an example of a query where you can select from this table. You can select the number of transactions that are processed, basically. Right? So very simple. And then from here, this is an example of what a customer, ENS, so you should probably know about ENS, right? Ethereum name system service. And what they do is basically they build this ENS dashboard that you can see here. Maybe I can try to open it, which is using Looker, which is another Google tool to create some kind of dashboard. And so what you can see here is basically how much money they've made, who is doing some registrations, renewal, and then active names, and so on, right? You can see the active users. So all of these queries are basically, hitting this kind of data sets behind the scene. So this is just an example of what you can, build, give some ideas of what you can do with these data sets. Okay. So I have another demo here. So it's a recording. So hopefully you can see it. All right. So here is a recording of. So you see here. Can you see my? Can you see it well? I don't know if someone can answer to me if you can see. I will take that for a yes. But yeah, it seems like you can see. So here is basically so that's the Google Cloud Platform, and basically in this demo here, there is a query. It's not on the Ethereum dataset or Injective. This one is on the Solana dataset, but it's basically trying to find the different blocks. Basically, what's the height of the chain right now? So at the time of the query, this was the result. It's just to show you how it can be used. And the interesting thing with this demo here is that we can use Duet AI. So Duet AI is a new functionality that is in preview, that is from Google Cloud, that is basically an AI assistant that you can use to create queries, use Google Cloud, do pretty much what you want within the whole Google Cloud console. So think of it as a personal assistant to do whatever you want. And so in this example, what I'm going to do in this demo is that I'm going to give a comment to explain what I want to do with this data set specifically. So I don't know if you can read here, but I'm basically saying, okay, show me the pub key and lamp ports, which is basically the Solana amount for this table. And then, cast the lamp ports as a numeric and then divide the lamp ports by 1 billion in order to be able to show in Solana how much accounts have, and then show the top 10. Sorry. And then show the top 10 results. Show the top 10 results of accounts at Solana, right? So that's a comment, and maybe if you used something like Copilot, then you would be familiar with how it works. But it will basically, based on the comment, generate the SQL query. So here it generates the SQL query. You can see that it selects basically the pub key and then the Solana, which is a cast of the lamp port divided by 1 billion. And basically it knows all of that also because it has the Duet AI has access to the different schemas for the different data sets that are behind, right? So it can generate the query, and then you have the results here, and you can use that for creating dashboarding or stuff like that. So I think so. This is an example. Basically, the same idea is building some kind of like Looker dashboard, and behind the scene you have this data set. So you could imagine the data sets being injective, for example, and then pulling out this kind of information pretty easily using Duet AI to help you find the queries that you would need, or what kind of graph would be helpful. And here you see specifically we're looking at, okay, what are the NFT that were created for a specific period of time in order to see the kind of like the creator economy for the chain and stuff like that. So this is just a demo, but I thought it was pretty cool to show, to explain a little bit how it could be done. I couldn't do it on the Injective Labs because I didn't have access in time, but I did it on the Solana web. All right. So hopefully that gives you, an idea of what you can do with these data sets. And this demo is basically a good segue to what Google is doing in the Gen AI space, right? And then, of course, I will talk specifically about Gen AI for Web3 here. All right, one second. All right, so for Gen AI, what Google has in terms of stack, right, is this slide here. So you can see at the very top, you have basically pre-built solutions for businesses. They are built with like large model and Gen AI, very easy to use. They can be used by business users, builders, and Duet AI that is here for it's for Google Cloud, but also Google Workspace. So it would be Gmail and stuff like that, like Office. You can use Duet AI to create your email and then use Google a cloud platform and things like this, right? So this was an example of a business user application that I showed by using Duet AI. But then next, if you look at for like the developers a little bit down the stack, you see that we basically bring together the different foundational models, right, that we have, and then we give them the workflow control of conversational AI and the faculty of Google quality search and enterprise search, right? So if you, for example, let's say that you are Binance, you need to make sure that if a user queries your LLM or your bot, for example, you don't want to mention Coinbase, right? And so with this kind of like generative AI app builder, it's very easy to do that, right? To make sure that your user queries don't mention specific words, or you can also create a flow for like payment gathering. You can gather credit card information, wallets, addresses, and so on, and you can create some kind of flow graphically on the Google Cloud console in order to create a bot, right? And then also, like if someone is asking you a factual question, right? Like for example, how much is the fees at Binance when I do a trade? You don't want the foundational model to answer, right? You don't want the LLM to hallucinate and then answer whatever thinks the answer is, but you really want to use enterprise search, right? From Google, for example, and then integrate the results with the foundational model, right? And that's a very different approach because you want to basically give your documentation, give all this information to the LLM so that it can use this information instead of just creating an answer by himself, because the LLM in itself is the creative part, right? So the foundation model, the foundation model, the LLMs are the creative part, but I want to control. I want to really ground my data with my documentation, with the basically my enterprise search capabilities, right? And that's obviously very important. And then you have Vertex AI, and I think we'll see a quick demo of it a bit later. But it's basically for the practitioners, for the AI practitioners. So what you can do with Vertex AI is you can start with models, right? So you have specifically Model Garden that is able to find first-party, third-party, and open-source models. So I think we have around 100 plus models. So you have, for example, like Stable Diffusion, Llama, but you also have the Google first-party models. And then you can use them, modify them, find the API, you can fine-tune them, train them, distill them, create API access endpoints, and so on in a very easy way, right? Everything is from the Google Cloud platform. You also have like Juniper Notebook that you can use to create, like to use these models and then test them in a very easy way. And of course, all of this is built on the Google Cloud infrastructure. So we make it easy basically for you to consume kind of like a lot of different tools to create decentralized applications or create applications, analytics, or whatever using Gen AI. Okay. Here is a very quick slide to talk about the architecture. It may look complex, but I think, but it's really not. It's basically two elements. You have the LLM, on one side, which is frozen. It doesn't store the queries. It doesn't evolve or change based on the queries that you're sending, right? And I think that's a misconception that people have, that the LLM is changing somehow. But the LLM is basically the same for everyone, right? The LLMs are stateless. And then on the other, on the left side, basically you have your tenant, and that's where you have everything else. You have your data, you have the queries from the users, you have the adapter layers with your industry data, your documentation, and so on. And so when the tenant talks to the LLM, everything is encrypted, no one have access apart from you, and so on and so on, right? So it's very like it's very important to understand that. And another alternative that you have also is to deploy open source or your own models in your own endpoints in Vertex AI, and then running on your own machines as well if you want, and run your own task-specific LLMs like Stable Diffusion and so on. All right, so that's pretty simple here. Okay, so in terms of use cases, and I think that's pretty important, no one really knows where all of this is going, right? I think that's a fact, right? It evolves very quickly. It's awesome, but no one knows really what's going to happen. But what we can see is what are people doing with LLM, what are people doing that makes sense, right? And so we've basically categorized, and this is Web3 specific, right? We've basically categorized some use cases that we see customers doing or that we think makes sense into 4 categories. It's basically 1, giving, having complex data intuitively accessible, right? And 2, online interactions made conversational. So every time you need to interact with a machine, basically, right? Think customer success and stuff like that. And then you have content generation. So creativity, every time you have to generate some text, some image, some code, and so on, then you can use a content generation. And then the last use case, or the category of use case, is really around a bit more complex, but it's really the key, which is, okay, what model should I choose? How do I do, MLOps, and how do I train my data? How do I fine tune, and so on? And that's really and so for each of these different use cases, we have created and found some use cases here that could give you ideas as well for the hackathon, for example. So if we look, at content generation, you could use it to generate NFTs. You could use it, of course, to generate to have an AI assistant for coding, or you can also create personalized ads and stuff like that. And then you can have also customer success a bit better automated. I think I talked a little bit about it earlier. Developer productivity, and then complex data intuitively accessible. You can give a lot of PDF around your application, a lot of PDFs around your documentation. You can give it market research. You can give it like data sets, right, that we talked about, and then do analysis and say, all right, like what are the similarities between these different users, or something like that. And we see a lot of actors in all of these areas here getting started, and we're really at the beginning of using AI for Web3, right? And especially, I don't know if you followed, but there was MetaMask Snaps that was released recently, and you have some snaps that are using AI to give you insights like transaction intelligence that are using AI, and that I think is pretty cool, right? Like running simulate basically the output of the transaction, finding if the transaction is going to be malicious and stuff like that. Okay, so to recap, before I show a little bit of a demo here, Google Cloud provides state of the art in AI. Been working 20 years in AI, and then a lot of the tech, underpinning the AI that people use right now was invented by Google, and Google proposed not only these first-party models, but also open source models, but also tools, right, such as LangChain that we'll use in your demo that we'll see in a second. LangChain is an open source tool that orchestrates kind of like multiple LLMs. And so you can use these tools, you can use these models pretty easily. And then you have the end-to-end governance attached with the enterprise readiness that we offer, right? So, okay. So I basically have 2 quick demos here. And because the agenda is packed, it's recording, but let me try to, it's a recording. Let me try to show that. Okay, so here, Okay. So here what we're doing is, okay, you can see my screen, right? Here is what it looks like, how we can use AI capabilities within the GCP console. So here what you're looking at is you can see a prompt and a response. You can see the different parameters here. You can see the models that I'm using. So here I'm using text Python, and then you have the size of the model or the version of the model. Sorry, text Python 001. And then what I'm doing is I'm just asking the LLM here to create a smart contract for a Google token, and then I explain a little bit that it should have a test to revert if it transfers more than 1 million token. It should use roles and stuff like that. And so when I run this this query here, what we can realize is that the output is not great, right? It's not using roles. The output doesn't perform as expected. And so what we can do as a second step is we can give it if we can do some kind of fine tuning, and we can give some examples. So I think, wait, it's not here. Okay, I'm opening here. Okay, so here what we can do is give some examples to the LLM to kind of guide the LLM into the right direction. And so what I'm doing here is, so you see here, for example, I say, here is my input and here is my output. My input is, for example, I want a token test with a supply of 1 million, and then I give it the exact code that I'm waiting for, right? And I do this for a mintable contract. So then, of course, if it's mintable, then you have a function mint, and then I do it also for a posable contract, and so on and so on, right? So I give a few examples here in order to help the LLM provide a better smart contract. And so here I take the same query and I run the query on this new model now, or on the same model, but now with a context that is augmented with all this information. And so here it's a bit better. You can see that it has a require that the number of tokens is below a certain threshold, like we asked, and we can see that it's using some kind of roles and so on. But the results still not perfect. And the reason why is because basically I'm not using I'm using text Python, which is a generic LLM. So it's text generating LLM. And so if we use code Python, which is Google LLM for specifically created for generating code, then you can see that if I use this code Python code LLM, then I give the same kind of I give the same input, then the output now is perfect, right? It's basically what I want without giving it examples. And so the reason why I've done this simple demo is just to explain that it doesn't really matter. I mean, what is the most important is the choice of your LLM, right? If you want to do things right, you have to find the right LLM. It doesn't matter if it's if it's more expensive, if it's bigger. What matters is that it serves your purpose, your use case. In this case, code Python is the right LLM to use, and the proof of that is that I don't need to give it any instructions. If I want to do this operation, I just use code Python, and then the result is perfect, right? And so that's very important, because you could manage to do it with another LLM, maybe Llama, maybe OpenAI, whatever the language, or ChatGPT, whatever the LLM that you would use, you might have different results, and you really want to try with the LLM and find the LLM that makes more sense with you. And then you can, once you found the right one, then you can fine tune it. Then you can do stuff like that. And you see here, so I don't do like a full tour and demo of the Google Cloud console and Vertex AI and so on, but you can see here that you have a Collab Enterprise, you have the Model Garden here, at the top left so that you can look at all the models. You can deploy them pretty easily. You can try pretty much over 100 models in a matter of a few clicks, which is really what makes sense. So you can use that during the hackathon if you want, in order to play with it and create some use cases for Gen AI. Another demo that is a bit more sophisticated that we've created with an AI specialist is how to use natural language to query data sets. Right. So to do that, we basically created a simple interface. You type natural language in English, and you say stuff like, okay, what is the wallet with the most number of transactions? And then we use LangChain to basically, find the different information that you would need from the data set, and then create the SQL query, and then hit the SQL the data set with the SQL query, and then return the results to LangChain, and then process it to give you the answer. Right. So the architecture at a high level looks at something like this. And so here is basically the results here. So you can configure the data set. So what I'm doing here is basically you can choose what tables to get the answers from. And so basically what happens in the background is that the LangChain would take the description of these different tables and would give it as a context to the LLM, right? And so my question here is, what is the wallet address with the highest number of transactions? And so you can see here what the LangChain is doing, the different steps that it's doing. It says, okay, so I need to get the different schemas, and then it says, okay, I'm going to generate the SQL query. So you can see that it creates the select from address, count as, and so on and it selects that, okay, it will use the transactions. Sorry, to put it back. So it is going to use the transactions table and not the balances one. So it understands a little bit, okay, what it can do. It could do joins as well. But yeah, here is just a simple example of how it's used. And then it gives you the answer, right? And so you can take this address here, run it on Etherscan, and look at what is the address with the highest number of transactions. All right, so that was that's it for the Gen AI, right? Hopefully you have a few examples of what can be done, what Google is doing specifically in Web3 on the Gen AI space. And now what I want to do is talk. We still have a little bit of time. I want to get some time as well for Q&A, if any. But I want to talk a little bit about ZK. And the reason why I want to talk about ZK is because it's it's a hot topic. A lot of people talk about it. A lot of people talk about it for ZK rollups, that you probably heard about. But a lot of people talk also about it for privacy solutions and for privacy reasons and for like DID and whatever use case that you might have heard of. And so I want to demystify a little bit how it works with a simple approach to it, and then explain why Google is doing something in the ZK space, right? So very quickly here, zero knowledge proof is a way of proving the validity of a statement without revealing the statement itself, right? And we'll take an example because it can be a bit confusing, but that's basically the strict definition of it. And I think there is two common misconceptions that people think about when we talk about ZK. The first one is that ZK is a direct correlation to crypto and to blockchain, right? So obviously it's not true, right? Because ZK was first introduced, I think, in the 80s, and the term was coined in the 80s, and it's a cryptography and mathematical problem, right? Before everything else, and before we talk about it here. And also there are a lot of applications to ZK that are non-crypto and non-blockchain related at all, right? So people, at the end of the day, you don't need the blockchain, you don't need crypto to do something, to use ZK and to do something with ZK, right? And those are big misconceptions that I hear about often. So yeah, very different. And the reason why it's different, and we'll take an example of what it is, right, to really understand what ZK is, because I'm sure it's still a little bit obscure, is to do a parallel with this game. That is, where is Waldo? So Waldo is the small, character that you have on the bottom left here, and the game is basically to find this character inside this book, and every page you have is basically very hard to find because the graphics are a lot similar and so on. And so in this case, Waldo is approximately at the center of the page here. But what is interesting is, and the parallel to ZK is, what if someone tells me after I've been looking for 10 minutes for Waldo, that Waldo is not on the picture, right? He's telling me, oh no, it's impossible, right? It's impossible to find Waldo because Waldo is not on the picture. So in this case, if I know where Waldo is, what I want to do is to prove that I've located Waldo to this person, but I don't want to tell them where Waldo is. And this is a typical ZK proof problem, because you know the location of Waldo, you want to share, to the person, you want to share that you know where it is, so that he knows that the game, is valid and that this person can find Waldo. But you don't want to tell them, because then there is no fun for them anymore, right? They can't play the game if you tell them where Waldo is. And so that's really what ZK is about, is to resolve exactly this problem. And so the person who knows where Waldo is basically the prover, and he has to assure to the verifier, which is basically the person who is looking to verify whether we know where Waldo is, that we have located Waldo. And all of this without revealing Waldo's location. Right? So that's basically the idea behind ZK. So if we recap the rules here, it's basically, we want to show that we know where Waldo is without them knowing where it is, right? And so to do that, a physical way of doing that, in real life, would be you take a huge black paper, and then you cut a hole in it that would be the shape of Waldo, and that would be the size of Waldo as well. And then you place this, so that would be step one. And then, of course, the verifier exits the room. And then the person who knows where Waldo is would place this cut hole of Waldo exactly on top of Waldo. And the painting of the rest of the game is obstructed by the black paper. And then now when the verifier comes back, right, into the room, and he sees Waldo through the cut hole, he knows that, okay, this person really has the secret that they are talking about. They really know where Waldo is. So it means that Waldo exists in this picture, even though I don't know where it is. And that's the whole beauty of ZK, right? So if we recap here, in ZK, you have the prover, which is the person who has the knowledge of the location of Waldo. You have the verifier, who is the person who checks the proof and verifies that this knowledge is basically valid. And the proof is basically, in this case, the whole system around Waldo and the cut hole paper and so on. And so it's a zero knowledge proof because the location is not revealed to the verifier. And so, yeah, I don't want to talk too much about why it's more complex in real life, because maybe now it seems a little bit easy, but because all of this is, arithmetical equations and so on, the whole logic of what you want to prove has to be translated into mathematical equations and what we call a proof system. And to convert this logic, or some of this logic, is very hard. If you want to prove like a simple thing, like an addition, without showing the two numbers, it's pretty easy. But then if you want to show, something a lot more complicated, then it becomes very complicated. And what people are trying to do when they do like ZK rollups, for example, is that they are trying to, for each EVM opcodes, they will try to have an equivalent of a proof system to prove every opcode, because when you want to run, a smart contract in this and have a proof that the smart contract logic is correct, then you would need to to prove that the opcodes have been executed correctly. But how do you do it for something like a create, for example, right? Opcode. That's very complex to do. And that's why we talk about like EVM equivalence and stuff like that. But I won't talk too much about it. I think what's more interesting is knowing if you want to do something in ZK, and if your hackathon, you want to do something in ZK, the most important question is, what is your Wilder? Right? That's really the most important thing. The Wilder could be ensuring PII, right? Like, or ensuring like privacy. So, for example, you could have something where you want to prove that you have over a certain salary, or that you own, I don't know, like you own a CryptoPunk, for example. You want to prove that you own a CryptoPunk, but you don't want to disclose what CryptoPunk, right? You want to prove that you earn that you have more than 1,000 ETH in your wallet, but you want to disclose exactly how much. This is the typical applications that can be done using ZK around ensuring privacy. But Wilder could also be about dispute resolution, right? So you can also prove that some code has been executed without having to share the whole database or the whole execution loop with the person. And thus, you're saving a lot of computational power. And that's basically what is used in ZK rollups, what I've just talked about. The ZK rollup is all about that. The ZK rollup is, instead of doing the execution of the code of the smart contracts and of the transactions inside the layer 1, I will do it off-chain, and then I will prove on-chain that I've done the work, saving a lot of computational power for the layer 1, and thus making it cheaper and more efficient, right? So maybe that gives you some ideas to do other stuff. But that's the idea. And yeah, you can also prove ownership, so I talked a little bit about that. But basically the main idea is, what is your Wilder? And lastly, I just want to talk about three main use cases. I mean, when people talk about ZK, usually they talk about privacy, scalability, and then some kind of like KYC, PII stuff, DID, whatever it means. Two are live, right? And so two examples here. Zcash, created in 2016, you can basically send private transactions. They are using ZK, and you can use basically ZK proof to prove to everyone that a transaction is correct without revealing the sender, the recipient, and the amount. Right. So it's really using ZK for privacy. And ZK rollup is proving to the layer 1, as I explained, proving to the layer 1 that the execution of the transactions and the maintenance of the database and so on that is done off-chain is correct, is basically valid. And so if you follow a little bit, I think there's another misconception that I would like to debunk here, is that when you use a ZK rollup, transactions are, yes, cheaper, but they are not faster. And that's a big misconception that I hear often, and there is a big difference. The time that your transaction will take from the moment you sign your transaction on MetaMask, on whatever wallet, and the time that the transaction is finalized is going to be longer if you use a ZK rollup, because you have to do more steps, right? You have to batch it, then you have to create the proof, you have to send it on the layer 1, and so on. So it's going to be longer. It's not going to be faster, but it's going to be cheaper. You're going to batch a lot of transactions, and then you're going to be a lot cheaper. And then basically the ones that is the idea is all around KYC, PII, and so on, which is a bit complicated because of regulations as well. Because if you trust that someone has done the KYC properly, do you really want to trust that this person has done the KYC properly and stuff like that? It's always a bit tricky to talk about this kind of stuff, especially for regulation, but it's an idea that a lot of people talk about. DID is obviously something that a lot of people have been trying to crack. And so, what Google is doing in ZK is basically we provide infrastructure for it. We provide specialized hardware, because running creating a proof for a ZK system, a ZK proof system is very expensive, very it needs a lot of hardware, basically a lot of computation. And so we provide like specialized hardware for that. and the more proofs you want to generate, the more it becomes efficient to use Google Cloud for that. And it's basically something that we worked on with Polygon, and that's why the reason as well why we are working together on this whole CK thing. Okay, so I think we have 7 minutes. So very quickly, the last slide. Google has a Web3 startup program, and so you can have basically some free credits, even if you have done like a token or NFT raise and so on. So you can apply using the QR code here. And as part, you have a link here. As part of this Web3 startup program, you also have some discounts to use some services like Alchemy, and you have a few other partners that you can use with discounts. So take a look at the startup program and have fun for the hackathon. Hope you learned something. And yeah, we have 5 minutes. I don't know if there are any questions.
Perfect. Yeah, I think we do have a few questions majorly related to. Okay, so someone from Binance asks, is it possible to get a copy of this presentation? So, when you go on the hackathon page, there is a tab which is called Workshops. And when you just scroll down, there will always be a link which would be attached to these. And you can find all of these workshops are actually uploaded on the YouTube channel of DoraHacks. So you can go there, and any developer resource that we mentioned is always linked in the developer resource tab. So you can always access it from there. Yeah, I think that's pretty much it. It looks like everyone is on board with the presentation today. Thanks a lot,
Awesome.
Adrien. It was, yeah, super
Yeah,
helpful.
no worries.
And
I was very clear, hopefully. And yeah, don't hesitate to reach out if you have any questions or any requests. We'd love to hear some feedback. Yeah, thanks a lot
perfect.
for
Yeah, so
doing
for
this hackathon, and hopefully we see great results, great
perfect,
ideas.
yes. Hoping the same. So for anyone who wants to reach out to you, what would be the best way for them to do the same?
Sorry.
For anyone that wants to reach out to you, let's say they're
Yeah.
stuck somewhere or have any questions, what would be the best place to catch you?
All right. So yeah, maybe send me an email. How can I share my email in here? Can
We
join the
can put it in
chat.
the, yeah, we can, you can put it in the private chat, and then we can put it in the YouTube live comments.
I need to connect to comment.
There's also a private chat option, so you can just put it over there, and we'll paste it in the comments.
Okay. Okay. I can't see it right now, but I will send it to you on Telegram.
Perfect. Yeah, that sounds good. And yeah, everyone who's building for this hackathon, I would wish you guys a very good luck. We have a lot of more. We have a lot of other workshops which we've also lined up to help you guys kickstart your journey. Definitely one of the kind of journey. We have 100K in prize pool with 3 different tracks in the hackathon. Good luck to everyone, and thanks a lot, Adrien, once again, for taking us through the entire Google Cloud workshop.
Thank you so much. Good luck, everyone.
Good luck, everyone. Bye.
Bye bye.